Hello guys, welcome back to another episode in the Becoming a Cairo series. In today's episode, we take a look at enums. We're going to be looking at enums, we're going to be looking at popular match statements and so many interesting stuff. So if this is your first time joining the series, I'll advise you to go back to check out the previous episodes so you can easily follow this particular episode. And of course, as always, please like, subscribe, and share this video with someone else if you find it helpful. And yeah, without further ado, let's get started. So enums are short for enumerations and are actually one of my favorite custom data types, right? So you basically want to use an enum in cases where you want to represent different variants of a particular thing. Now, let's for example say we have a parameter called color, and in that parameter we want people to pass in either a color red, green, or blue. So it has to be either of these three colors or it's invalid. Now you want to represent something like this using an enum, right? And what's going to happen is if you have an enum called color, this is going to have like three variants called red, green, and blue. And you can always check against these variants to see if that parameter subscribe to any of these variants. And if it doesn't, you know that, okay, this parameter is not valid. So this is like just a simple example of how you use enums, right? And like I said, in this particular episode, we're going to be learning how to actually create custom enums, right? Creating enums, how you can instantiate them and how you can check against them, right? Using what we call the match statement. So, let's just dive into our code editor and start playing around with something. Yeah. So back in our code editor, the first thing we're going to do is, as always, is we're going to create BAC8 and let's call this enums. All right. And let me just save this. Okay. So in here, as always, I'm going to make a new directory. I'm just going to call this enums for now. Or sorry, rather I make a new directory. Let's just do scab new. And let's call this enums. So we're just going to bring it just the basic Cairo package. All right. So I'm just going to clear that. And yeah, as always, let's just rename. So I'm going to close this. And I'm going to rename this to BAC8. Okay. Now I guess we're good. So I'm just going to CD into BAC8. All right, so we're good to go. All right, so I'm just going to go into BAC8 this time around. Let's just do stuff in the lib.cairo. I'm just going to clear that. And now the first thing we're going to be doing is learning how to create enums. Now to create an enum, you just simply use the enum keyword, right? And let's say I want to create an enum called colors. And like I said earlier, I want enum to have the variants red, green, and blue. So this is just how you would create an enum, right? It's that simple as this. Now, just like structs, you would want to like derive the drop trait, right? If you don't understand why we are doing that, I would encourage you to like go back to check chapter, that should be chapter 5 where we discussed understanding ownerships. All right. So now what we just did was we just defined an enum called colors, and this enum has like three variants, red, green, and blue. Now the question is, how do we instantiate this enum? So I'm going to create a new a main function, right? And within this main function, I'm just going to say let color. So let's say I want to instantiate the red color. So I'm going to just simply say let color be equals colors red. And just using that, I just instantiated an enum called, I just instantiated a new value, right, from an enum called colors. All right. Now, enums are not just used to store variants, right? But you can also attach or associate values with these variants. So for example, let's say I want to store, okay, let's create another new enum to describe this. So for example, let's say I create an enum. I'm going to call this enum direction. All right, and this enum is going to take four values. So we're going to have the north direction, which is going to be in 64. We're going to have the east direction, which is going to be a in 64. We're going to have the west direction, which is going to be in 64, and we're going to have the south direction. This is going to be a in 64, and nums can hold a lot from not just what's it called, integers and filters, but it can also hold other data subtypes such as tuples and structs. Now structs are actually okay. Let's demonstrate how we probably like store a struct in an enum, right? Or instantiate an enum of a type struct. So let's say we have like a new struct, and I'm going to just derive a drop on this once again, and I'm creating this new struct. I'm going to call this struct northeast, right? And this struct is going to have two members: the north value, which is going to be of in 64, and the east value, which is going to be of in 64. Now we can actually create the northeast variant. You can create the northeast variant, and we're going to simply say this is going to be of type northeast. So just with this, we just instantiated we just created an or defined an enum, right, whose variant is actually of a type struct. Now how would you probably instantiate something like that? So we just created this enum, right, and it has like a variance that has like a struct type. So let's for instantiate the normal one. So if I wanted to, let's say, instantiate this normal one that just has like a simple integer associated with it, right? Let me bring this down a bit. I can do something like let not be equal to direction not, and I can just pass in, let's say, 30. So let's assume this is actually degrees, right? I'm saying, oh, for the direction, right, it should be 30-degree note. That's how you can basically instantiate it. So let's say I'm trying to instantiate the one which like has the struct, right? So I'm going to call this northeast. We can actually instantiate that like this, say direction, and this is going to be of the northeast variant. And now remember, this takes in a struct type, right? So I'm just going to instantiate a struct inside, and this struct is going to have the north value, let's say 30, and the east value, let's say 70. And that's just how you probably like do something like this, right? And that's just all about how you can actually define enums and instantiate the values. Now let's hop back into our Cairo book. All right, so we just covered enum variants and values. Okay, we've covered how you can combine it with custom types. In here, they combine with a tuple, or we tried using a struct. You could actually try instantiate defining an enum with a tuple, right? You can actually use you can even actually define an enum that uses another enum too, so that's possible. But because of time, next thing we're going to be looking at, right, is how you can actually write trait implementations for enums, right? So I think that was just in the last episode we looked at how you could actually define like custom implementations like on traits, right, for custom data types such as like structs, right? You can actually do something similar for enum. So let's hop into our code editor and see how you probably achieve something like that. So all right, now back into our code editor. Now we want to write, let's assume we want to write like a custom implementation, or a custom implementation, right, that probably moves in a particular direction. So this is going to be implemented on the direction enum. Now what I'm going to do is I'm going to start with defining our traits, right? So let's call this move traits. I'm just going to say call this move traits, and what move traits is going to define is a simple function called move that takes in self, which is supposed to be like a direction, and then just prints out something for now. All right, so I'm going to create this implementation. Let's call this move implementation or move trait. Okay, and this implements the move function, which takes in the direction, and what we're just going to do for now is just we're going to print out this line that says you just moved. Okay, so Now, how we're going to simply call this, right? So if you checked out the last episode, you should be able to do this even before I do it. So you can just pause the video and try to do it yourself. All right. So I guess you were able to do it, right? So what you essentially just need to do is, you can just do, let's see, called not.move. Now you can access it using dot notation because essentially this move is now a method implemented on the direction enum. So we can actually access it using like the dot notation. So if we just do that, and we're going to try to run again, so scarp Cairo run, just forget the warnings. So you can see it says you just moved. So essentially you were able to print like whatever was or implement whatever was in this method, right? Just by calling it using this dot notation. All right. So back into our Cairo book again. Let's see what things we're missing out on. So we just looked at trait implementations for enums. Yeah. So another interesting thing we need to talk about is the option enum. So the option enum essentially is like a standard Cairo enum that helps us represent the concept of an optional value. Now in Cairo, we do not exactly have like the null pointer. So most times, right? Oftentimes you'd probably want to use like the option enum to represent cases where something can actually result to an uninitialized or null value, right? And it's like I said, it's implemented within like the core lib already for it's part of like Cairo language. And all it is, it takes in a type, in this case T, and it checks, okay, does this have a value? In this case, using the sum, right? So if we can do something like if it has a value, right, we want to return that value. If it doesn't, in this case, we want to like, what's it called? Return none. So let's see how we can actually do that. So we're going to pop into our Cairo book. We're going to go back into our Cairo book and we want to actually use the option type. So now what we're going to essentially be doing is we're going to be implementing it on like a very simple array, right? And then we're going to be checking is, okay, does this array have a value? If it has a value, what do we want to do? We probably want to just print out the value. If it doesn't have a value, okay, we want to like just print out something else. So let's see how we're going to do that. So we're going to come into our main function, right? So here I'm just going to say, using the option type. All right. So what I want to do now is I'm going to create a very simple array. So this array is going to be of felt 252 values, and I'm just going to simply initialize a simple array. All right. So this array can either contain no value or a single value. So in this case, so let's say I want it to contain a single value called 10, right? And using the option type, what I'm going to do now is, so I'm going to be introducing a new thing called the match construct. So we're going to be talking about it in details when we move to like the next subchapter. But for now, let's try to just use it because that's the only way I can actually like effectively use and describe the option enum for us right now until we get to the last subchapter where we talk about concise control flow with if let and while let. But for now, let's just use the match statement. So we're going to call match and we want to call it on the pop front. So the pop front, when we looked at arrays, right, we said pop front is one of the methods implemented on, implemented on arrays, right? You can actually call to like remove an element from like the front of an array. All right. And something we've probably not mentioned not till now is that the pop front returns an option of like the box type. So essentially in itself, it returns like, the option enum, right? So it means we can actually use a match statement on it. So don't worry, we're going to explain the match statements in details once we get like into the next subchapter. So now I want to match on the results of like the call to the pop front, like I said, which returns an enum. And I'm going to say if we have a value. So all sum does, right, is check that if there's if that option or whatever it's is being matched on, right, if it has a value. So we're going to say if it has a value, we're just going to, sorry about that. If it has a value, I just want to print that particular value. So I'm going to say the value is whatever it is we printed. Now this implementation doesn't like make the most sense, but we're just trying to explain how you would want to like use the option enum, right? So we want to say if it has some value, if it has any value in it, right, we want to just print out that value. And if it doesn't, in this case now, if there's no value, we can represent this using the none. If there's no value, what do we want to do? We're just going to simply print out and say array contains no value. All right. And within match statements, you separate your what we call the match arms using like a comma. So we're going to explain that like in the next subchapter. So just be a bit patient with me. All right. So what we're just saying is we're calling array the top front, like I said, which returns the option enum, and we are now matching on that and saying, okay, if there was a value, we want to print out that value, and if there's no value, we should just print out array contains no value. And thus, let's see when we run this. So just going to clear this and scrap Cairo run. So as you can see, it returns the value is 10 because there was a value contained in the array. So now let's try to see what happens if there's no value. So I'm going to clear again and scrap Cairo run. So as you can see, it prints out array contains no value. So that's exactly how you want to use the option enum, right? So essentially it has two variants, the sum, which is basically called which basically checks if something has a value, right? Contains some value, and none, which you basically want to use, probably call against like when it has no value. So like I said, there's no null pointer in Cairo, so the null type does not really exist. So you want to probably use an option type anytime there is a chance of something being null, right? So it helps you to prevent unnecessary bugs, and I think it's actually a lot very expressive. All right, so I think that's all you need to know about the option enum for now. So let's hop into our Cairo book and just check out the next things we need to cover. So we just looked at the option enum and its advantage. Yeah, you could check out this example to probably like get a better grasp on like the enum. Well, I avoided it because it contains some things we are going to be looking at in further subchapters. So let's just keep that till we get to like the subchapters for those particular examples. All right, so enums can be useful in many situations, especially when using the match flow constructs, which like I said, we're going to be looking at in the next subchapter. So there are other enums, of course, which you would also find in the core library. For example, the results enum, which basically you want to use either when you return something, if something is successful, or if something like returns an error. So it has the T and E variants you can actually match against. And we're going to be looking at that in details when we get to like the error handling chapter. That should be like about 2-3 chapters ahead. All right, so let's take our quiz so we can move into like the next subchapter. Okay, it says determine whether the program will pass the compiler. If it passes, write the expected output of the program if it's executed. So here we have x set to null, and we're calling this full function with x. So automatically we should know this will not compile. That's because, like I've said over and over again, Cairo doesn't have a null pointer. There's no, the null type doesn't really exist, so that will not compile. So next up it says consider these two representations exact. So this is the result type we just talked about, right? So it has the OK and the error, and you probably want to match against this. So OK is returned when like probably like a particular operation was successful, even though it returns like an error. All right, so we have the struct result one. So it said consider this two representation of a result type that contains a value T if a computation succeeds, or an error E if it fails. Okay, so this is a struct, this is an enum. So it says the enum result 2 is considered more idiomatic than the struct in Cairo. Which statement below is not a valid reason why? So the struct option types, which are only intended to wrap structs, the structs uses more space in memory at runtime than the enum. The struct could have OK and error both be known, while the enum must have at least one of them. The struct is more syntactically verbose to construct than the enum. So it says the enum result is considered more idiomatic than the struct. So which statement below is not a valid reason? Okay, it's not. All right, so the struct contains option types which are on the internet to route structs. The struct uses more space memory at runtime think it's valid. The struct could have okay and error both be known. This is valid. The struct is more syntactically verbose to construct on the enum. So this is actually the correct answer. All right. So we got our both answers correct. And I hope you actually tried that out before I did, right? So that's something you should actually try. I always forget to mention it, right? But anytime we get to the quiz section, you can actually pause the video and try it out yourself. Then probably check out the answers later, or you could actually just check out the answer directly from the Cairo book. So, but anyway, we just completed that quiz. So we're going to head into our next sub chapter. All right. So in this sub chapter, we're going to be looking at the match flow constructs. And I think the match flow construct is actually like something very powerful that makes enum very beautiful to use, right? So I usually used to prefer to think about the match flow construct like the if flow, except that in this case, right, you know how the if, for example, the statement, the if is actually checking against must be Boolean, right? So it's match, it can actually be any value, but that's not like a very definitive way of defining the match statement, right? So I like this example they used in the Cairo book, right? So you can actually think of a match of the match expression like some sort of coin sorting machine, right? And basically you have coins sliding down a track, and there are of course various holes, and when it gets to a particular hole where like it fits into, right, it's just going to fall directly into it, and it's just going to continue, right, till we get to like the last stop. And something you need to know, but note about the match expression, right, is it has to be exhaustive. So if you're using the match expression, it has to cover every nook and cranny, every possible variant of your enum. So let's just dive into our code editor and play around with the match statements. All right, so back into my code editor, and we're going to, for this example, we're just going to was going to still as well stick with like the direction enum. So I'm going to come here and I'm going to match against each direction, and I'm going to probably print out something else. So for just to make this more pleaser to the eye, I'm going to create a new function. I'm going to call this function like get direction. And this function get direction is simply going to take a direction which is of type like the enum direction, right? And what we want to do is we want to match against each direction. So we want to match against this direction value we get, right? And like I said, a match statement has to be exhaustive. So we want to check against each and every variant, and if there's a particular variant that it matches against, right, so we're just going to print out what is associated to that particular variant. So for example, I can do something like for direction not, what do I want to do? So I'm going to simply just I'm going to print out direction. Let's say the direction is not. Okay. And I'm going to explain basically how like the architecture, or how, yeah, I think the architecture of like the match flow construct looks like. But let's just complete our match flow first. So I'm going to say, so what are our available variants? So we have north, east, west, south, and northeast. And yeah, northeast. All right. So I'm going to implement east, and I'm going to say for east, I want to simply, I'll just copy and paste. So our life is a bit easier. So I want to just print out the direction. This is, so this is supposed to be double as of that is cried. So when direction is west, we want to print out that the direction is west. And when direction is south, we also want to print out that the direction is south. All right, so I think one last thing we have to cover is the northeast. So we're going to say when direction is northeast, right? I can just print out something simple, say the direction is northeast. Yeah, so I'll just hyphenate that. direction is northeast. All right. So this is just a very simple match flow construct, right? And basically you specify the match expression using like this match keyword. The next thing is what you're matching against. In this case, like the direction, and this can be like of any value, right? Of any data type. So in this case, what we're matching against is the direction. And like I said earlier, what's it called? So this is wrong. This cannot be of any data type, but you can evaluate to like any data type. It doesn't have to like evaluate to a Boolean value. That's what I meant actually. So, but, remember, like we have like different variants, about 5: north, east, west, south, and northeast. So what we essentially do, just like the coin slider that the Cairo book described, right? We're simply saying, okay, check against the first variant. Does it match against the first variant? If yes, we want to like, carry out this action. Now, this particular part is called the match arm, and this particular part is basically like the pattern, or like the resulting effect, what you want to do if like it matches like a particular arm. So we're saying, okay, for example, if we passed in the north direction, we want to simply evaluate to this. If we pass in the east direction, we want to evaluate to this, and so on and so forth. And you have to separate your each of your match arms, right, using a comma. So if you say a semicolon, right, so you're going to like the compiler is going to shout at you, so you have to use like the comma to separate each of your match arms. Now, something else you could actually do, right, is, well, for example, in this case, you notice we just go ahead to like just write out whatever we want to, the resulting effects we want, right? But imagine in a case where you want to like probably write out a more complex logic. In that case, you probably want to like you want to wrap your effect, the resulting effect, or whatever it is you want to deload your logic, right, within what's it called, this curly braces, right, this and this, right? So let's say, for example, we didn't just want to just print out the direction. Yeah, something else I forgot to mention is you can actually pass in values. So for enums that actually have associated values, in this case, like all our enums have associated values, right? For enums that have associated values, you can actually like get those associated values. So let's try to use for the struct, which was like I think the most complicated value we passed in. So let's say we want to get the value associated with the struct. So I'm going to get that into a value called northeast. Now, what do I want to do? I want to print the value. Let's say, okay, the direction is northeast at degree, or let's say at east degree. So let's just print the east value, right? And remember, we have the northeast struct, and the northeast struct in itself contains a north and an east member. So we want to print the east value. So we're going to say the direction is northeast at east degree, and we're going to just simply get that by saying northeast dot east. All right. So doing that, we automatically have access to like the east struct member within the northeast struct within the northeast enum variant. I hope that's not like a lot of information to comprehend. You'd probably like wrap your head around it as we go further. So now let's try to call this get direction function. So in here, I'm just going to call this using the match statement, or the match expression. All right, so I want to call this get direction function. So I'm just going to say get direction, and to this get direction, I'm just going to pass in. Okay, let's pass in the northeast in this case, so that we're able to like see if this value gets printed out. All right, so the northeast, we already got that. We already instantiated that, so we're just going to pass in that value northeast. Sorry, okay. All right. So we're passing that value northeast. All right. So let's try to run this and see what we get. I'm going to clear this again. And scarp Cairo run. All right, so you can see it gives us the value. It says the direction is northeast at east degree 70, right? And so you can see that in here, we actually instantiated the struct to actually be the east value 70. So you can actually do same for any of this associated value, right? So you could actually just say passing north And for example, in here, direction is not at degree, and just print out that not value. So you can actually just easily do those. All right. So something else I've been mentioning over and over and again, right, is that the value of a match statement, right? So that when you're matching against an enum, the match expression has to be exhaustive. So in here, in our direction enum, we have like a 1, 2, 3, 4, 5 values. So let's say for some reasons we decide to like remove one value, right? We decide to omit one value. Now we're going to have a compiler shout at us. Let's try this. So let's try to build this. So you're going to see we have an error which says missing match west. So in this case, where for some reasons, right, we do not cover the we probably did not want to like cover a particular match what we can rather do is use something use an exhaustive, like use what we call it's like a catch-all placeholder, right? And all this is basically telling the compiler is okay, any particular match that was not found, I just want it to do this default thing for it. So we're just going to say print the default value is west. Okay, so remember, no semicolons. All right, so now let's try that and see if we're still going to run into errors. So right now we can see we built our values like successfully. So what if we now try to instantiate, let's say we say let west be equal to direction west, and we want to pass in a value maybe 70, right? And we just pass in west. Now let's see whether it prints out what's in this placeholder, right? So I'm just going to clear this, and I'm going to say scarp Cairo run. All right, so you can see it says the default value is west. And yeah, so that's how you basically want to represent any value you explicitly do not really want to cover. So let's hop back into our Cairo and see if there are any other thing we are like kind of like missing out. So all right, so we've pretty much gone very far. We've looked at patterns, binding values. We've looked at, we previously looked at matching with the option enum, right? And so we just talked about how matches are supposed to be exhaustive, and how you can actually use the underscore placeholder to like to basically catch all. Now, something else I forgot to mention, right, is you can actually use the or operator with match statements. Now let's head back into our Cairo book and see how you probably do that. So remember we removed the west, right? So we removed the west. So we could actually do something like if direction as this, or direction is west, then we want to like print out this. So for this case, let's not do it there because not has a value and we really do not want to complicate it. So I'm just going to come and do it here instead. So if direction as east or direction is west, right? We want to just print it out. Let's say, okay, print the direction is east or west. All right. So now when we do this, we now have the west arm covered. So we can simply just take this off and we shouldn't have the compiler shouting at us again. So let's try. So I'm going to clear this and try again. Scarp Cairo. So as you can see now, it tells us the direction is east or west, which was basically what we did here. So, the match flow, right? It's matched against the west in this case. So we're saying if it matches against east or west, right? We want to print out this, and it matched against west, and that's why that was printed out. And that's how basically you want to use like the operator with match statements. All right. So back in our Cairo book, yeah, something else is you can actually match against tuples. You can also match against like integer variables. So let's just go into our code editor and try like matching against integer variables. So what I'm going to do now is I'm going to create a new function, let's create a new function. Now this function, let's call this roll dice. All right, so this roll dice is going to take in a value, right? And this value is going to be like a felt 252. So remember how we used the match statement, right? The match expression against enums. You can actually also use them against like other data types like felt 252s, integers, and even tuples, right? But there are like some limitations for, let's say, if you are using them against like felt 252s and integers, some common limitation you're probably going to face, one is that the value of like the integer, right, has to fit in a felt 252. So because of this particular limitation, it means you can't match against like stuff like a in 256, right? You can't match against a in 256. Another thing also is, right, when matching against integers, right, is that the first value of your match first value must always be 0. First value must always be 0. And the third limitation you actually have, right, is that you must actually use like this catch-all placeholder to account for any other, because think about it, when we are matching against integers, you have like a large range of integers from 0 to God knows, right? And so you might want to actually match against a few integers, but then, like I said, match statements have to be exhaustive. So you have to use the placeholder to represent every other integer that is not exactly covered. And those are like, and then for tuples, I think the only limitation is that the member of that particular tuple, right, has to be an enum. So if it's not an enum, it's not your match statement is the compiler is going to throw an error. All right, so now we want to try to, in this case now, for a roll dice function, we want to roll a dice, and depending on the value of the dice, we want to we want to print some certain things to the terminal. So I'm going to match against this value. And like I said earlier, the first value of your match statement has to be 0. So now I want to see if the value is 0, or the value is 1, or the value is 2. I want to actually print you won. So you rolled your dice and you won, right? So, but if maybe you got printed, if 3 or maybe 4 got printed out, right? Want to maybe passed in 3 or 4 as a value, right? Want to print roll again. So let's say roll again. But if you got any other value that's not 0, 1, 2, and 3 and 4, what do you want? Simply, do you want to just print out? Once print out, oops, you lost. You lost. All right. So you can notice this our match statement subscribes to like this 3 limitations that I mentioned earlier, right? These 3 restrictions. So one, the value of the integers fits in a felt 252. So we're using a felt 252 to automatically make sense that it fits in, right? So the first value must always be 0. In this case, as you can see, our first value is actually 0, right? And then we actually use the catch-all placeholder to catch any other integer. All right, so now let's see, when we call, let's just say matching against, let's just say other data types. All right, so I'm going to call the roll dice function, and I'm going to pass in 3. All right, now let's clear this and scrap Cairo run again. So it says roll again, right? So we said if you get 3 or 4, you roll again. So now let's try to maybe let's pass in, let's say like 300. What happens when we pass in 300? We run scrap Cairo run again. And as you can see, we get printed out, oops, you lost. So any value passing here, 1,000, 1,000,000, 1,000,000,000, you're going to get like this last match statement, right? That's why it's called the catch-all. All right, so let's hop back into our Cairo book and see if like we have any other thing left before we take our quiz. All right, we just looked at matching against filters and integer variables, and yeah, so we're going to take our quiz. So once again, you can actually pause the video and take the quiz yourself, and we can actually like compare answers later. All right, so I'm just going to start the quiz. Now, determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. So we have this location enum. It takes in a point which has an associated value of a uint32, range which has a tuple of uint32. All right, now we have the main function. We get the location. We instantiate the enum. Then we are trying to match against the location. Oops. Okay, we match against location. We get the first value. Okay, now we get the second value, and we're trying to match against R. This is not going to compile. That is because, like I stated earlier, if you're matching against the tuple type, the members has to be like enum, and these are no enums. The member of like the R is not like it's in this case range, right? It's not like an enum, so this is not going to compile. All right, so the next, determine whether the program will pass the compiler. We have this enum called either. So left has an associated value of uint32, right has an associated value of byte array. So off the bat, you just note this is not going to compile because this is a byte array, it doesn't implement the copy traits. It means this is moved into X and you can't really match against it. So this is not going to compile. So determine whether the program will pass the compiler. If it passes, write the expected output of the program if it's executed. So we're matching against an integer, just what we finished doing right now. So this is not going to compile. Why? Because we did not implement for like the catch-all operator, right? So what happens when I pass in 8,000? The match expression won't be able to like account for that. So this will not compile. So question 4, considers this method implemented for the option type. So function unwrap or match self option sum x option none default. Which sentence best describes the behavior of this function? Alright, returns any option containing the object inside self if it exists at default, otherwise no. Inserts default into self if self does not already contain a value. No, really. Returns a reference to the object inside self if it exists and defaults. Otherwise, returns the object inside self if it exists and defaults otherwise. So this is our answer. So essentially, if the value exists, we're just returning it. If it doesn't, we're returning the default. So that should be our answer. Now it says, consider these two implementation of a function to decrement an unsigned number twice. So in here, we get the uint32 value, match against it. If it's 0 or 1, we return the non option. Then we catch all, and for all we want to return sum with n-2. Okay, so this function decrease twice. Okay, if n is equal to 0, return the option none. If n is equal to 1, return the option none, else return this. So the function have the same behavior for, so essentially has the same behavior for all the inputs, because 0 1, same thing here, 0 1. So if it's 0 1, it returns none, and otherwise it returns like option. So it's essentially the same thing. So it's going to have the same behavior for all inputs. All right, so we answered the 5 questions correctly. I hope you did too. Okay, so you can just check out this extra context if you need them. So, but because of time, we're going to head into like the third sub chapter. So the last thing we're going to be looking at is the concise control flow with if let and while let. Now, these are actually syntaxes that enables you write like the match construct which you looked at earlier in a very much concise way. Now, I want to use this in cases where I don't really care for like other match arms, or like I don't really care for other values. I just want to check against a particular value, and if it matches it, I just want to do something, right? So one of the major downsides of using like the syntaxes, right, is they are not really as exhaustive as like as the match constructs, right? So, but let's dive into our code editor and kind of like play around with this. All right, so back in our code editor, and the first thing we're going to be playing around with is the if let construct. So I'm going to create a function, and let's just call this if let. Let's just call this if let. So once again, just for better organization. All right. So for the if let, let's assume we want to pass in. Okay, let's not pass in any value. So what we're going to do is we're going to be implementing like a simpler version of this rule, guys. And all we want to do, right, is if it matches, for example, or if it matches a particular value. So let's in this case say if it matches 2, we want to print that you won. Else probably if it doesn't match anything, right, if it doesn't match that 2, you probably lost. So we can just do something like we're going to instantiate. The first thing we're going to do now is instantiate the number that signifies our winning, right? And we're going to instantiate it as a type of like the option enum. So I want to pass in this case, okay, 2. So well, like I said earlier, if it matches 2, we're going to win, right? So what I'm going to just simply do now is I can actually just use the if let to say something like if let option, okay, let's say matches the sum value of x, right? We want to, sorry, if this, remember, it's not really a match construct. So I want to see if this value matches like the number which we created earlier. We want to just simply print. We're going to print that you won. Okay, we can also just so we use x, right? So you won with value, and we can just simply print out x. Now x can be anything, you can call it anything, right? So all we're just saying is if the option type, right, if it evaluates to this particular value, this particular option value, right, we just simply want to print that you won. All right, so I'm just going to simply call okay, I'm going to simply head in here, just call if let. So let's call this if let. All right, I'm just going to simply call if let, right? And yeah, so I'm going to come here, clear scarf Cairo run. So yeah, this is not exactly very exhaustive, right? Because it's basically we're just comparing against this. I was saying you won with value 2, so doesn't really make sense logically, but it's just we're just trying to explain how you would probably want to use like the if let, right? And it's more or less like the thing we do essentially with this catch all placeholder, right? You can essentially just do similar thing by adding like an else statement here. So if you print an else statement here and print you lost, and for some reasons the number value was probably something really dynamic and that could really change or something like that, right? You can actually compare against both, and if it's what's it called, if it's another value, right, you can actually print out that you lost. So that's like another way of actually representing the catch all. And yeah, we actually even saw that in like the last quiz we took, right? There was an example that actually looks like that. So that's essentially how you can actually use the if let. But like I said, this is not really exhaustive, and that's like the major disadvantage against like using something like the match expression. We could also do something similar. So there's also like a similar syntax for loops, right, using the while let. So now to do this, I'm just going to instantiate a very simple array. I'm going to let this array be 1, 2, 3, okay? And I just want to get the sum of this array, so I'm going to instantiate a value here. Let's call Let's instantiate this to 0. And all I'm going to do is I'm going to simply use the while let in this case now. So I'm going to see while let option sum. So while this is still going to get a value, in this case X, right? And it's going to the action we are trying to carry out in this case is pop front. Remember when I talked about pop front earlier? I said pop front returns like an option, like the option enum, right? Or the box type, right? So essentially it returns in terms of the option type, and so we can actually compare it against this. And all we're saying is if it contains some value, what we want to do is we're just going to simply add that value to our existing sum. So sorry, this, we want to close this. So what was it simply saying is we are checking if this maps like is equal to like the value. So if we remove the first value from the array, right, if there's still a value in it, we want to simply get that value and add it to like our existing sum. All right, and we're just simply going to, I'm just simply going to print out total sum. So we're going to say total sum is, so now we are getting an error. Let's see where the error is coming from. Those are missing tokens, expected an expression. All right, so let's debug where is that coming from. So function, well, so we're saying let's build array be equal to this particular array, and let's build sum equal to 0. So while let option sum x is equal to array dot pop front. So we simply want to add this. That's weird. So this should be correct. So why do we get this error? Hey, let me try to build this first to confirm. So all right, so that build. So I guess it's just something from my language. So my language, my language was probably just misbehaving again. So let's just try to run that. So using scarp Cairo run, I'm just going to try to run that. Once again, ignore the warnings. So as you can see, it won't valid, so it doesn't really print out our sum, does it? Why is that? Sorry, I'm just trying to read out this. Oh, okay. So I was saying, oh, right. So while it's not, it's because we forgot to call this. So I'm just going to call this here. Remember, our main function is always going to be our entry point. So if we don't really expose it here, it's not really going to be seen by the compiler. So we just want to expose this here. And here I'm going to clear once again and scarp Cairo run. So I want to print out the total sum. Yeah, so now you can see it says the total sum is 6. And so that's essentially how you're going to use the if let and the while let. And of course, like we did the last time, if you want to just ignore the warnings, we have color, which is unused. So we can just come here, add an underscore, and come here and add an underscore, and we'll get those warnings out. All right, so I think that's about all, but let's go back to our career book to just check we're not missing out on anything. Now, back in our career book, we just covered the if-let syntax, and we covered the while-let syntax. So there's a lot of read up you can actually you can check out, try to check out this, probably read out a few of these things to understand how the syntaxes work better. But because of time, we're going to actually stop here. So once again, if you have any questions, I'm always available for your questions. You can reach out to me on Twitter at CyrexTalentin or on Telegram at Talentin68. And of course, if you did like this particular episode, please, of course, give it a like, subscribe, hit the notification bell so you are informed every time we drop a new video. And yeah, share it with your friends, of course, if you did find the video helpful. And well, I think that'll be all. I'll see you in the next one. Thanks.